In 2025, deep beneath the Pacific's frozen arc, the planet prepared to release its hidden power. For centuries, two colossal plates have collided here, one diving beneath the other in a silent war. Pressure builds as the boundary locks, bending the crust upward by meters. At 10:42 a.m. local time, the fault snaps. Pling. A magnitude 8.8 earthquake shakes the seafloor. P waves race ahead, followed by slower S waves, spreading energy across the crust. The seafloor lifts abruptly, displacing billions of tons of water in seconds. From this motion, a long, low hump forms. The ocean itself becomes the weapon. The released energy equals 400 million tons of TNT. The surface seems calm, yet beneath it, an unseen monster travels faster than a jetliner. This is a 3D cinematic simulation created for scientific education. Within 10 minutes, pressure waves ripple outward across the entire North Pacific. Buoy sensors across the ocean detect abnormal pressure pulses, the first confirmation of a tsunami. Below, shock waves disturb layers of sand and gas, stirring the ocean floor. The wave accelerates across the deep Pacific, silent, massive, unstoppable. From a single rupture beneath Kamchatka, energy now races across an entire ocean. Beneath calm waters, the wave now stretches wider than the eye can imagine, a moving mountain of energy. Tsunami velocity depends on ocean depth. The deeper the water, the faster it moves. To anyone on the surface, the ocean looks ordinary. Yet a pulse the size of a continent moves silently below. As the tsunami expands, multiple wavefronts intersect, combining or canceling in complex interference patterns. Underwater peaks redirect and amplify energy, raising the wave even before it reaches shore.
Within 30 minutes, the wavefront spans more than 1,500 kilometers.
Energy never disappears querent. As amplitude lowers, wavelength grows, conserving the tsunami's total momentum. The Pacific's natural currents reshape the wave's path, bending it toward Hawaii and the U.S. West Coast. From space, satellites detect minute changes in sea level, just centimeters high, yet spanning the ocean. Deep ocean buoys confirm the wave's arrival, small surface changes, massive underwater energy. Island chains split and refract the energy, focusing destructive force through narrow passages. Inside the wave, trillions of water molecules move in circular orbits, the entire ocean breathing in slow motion. Even after thousands of kilometers, less than 2% of its power is lost. Sound waves accompany the motion set, a deep frequency humans can't hear, but instruments can record. After 1 hour, the tsunami moves freely across the Pacific, 6 hours from Hawaii, 9 from California. From orbit, the tsunami appears as subtle ripples crossing the vast Pacific, a signal of energy traveling faster than airliners. At the Pacific Tsunami Warning Center, algorithms convert deep ocean data into real-time alerts. Within 12 minutes of the quake, a regional watch is declared for the entire Hawaiian archipelago. Hours before impact, sensors near Midway Atoll record a faint rise, the ocean's first visible response. Buoy data confirms the passing pulse, barely noticeable on the surface, yet carrying catastrophic energy. At full speed, the wave keeps pace with a passenger jet, silent, steady, unstoppable. Even from 30,000 feet, the Pacific breathes with motion, an invisible heartbeat of the Earth. Temperature and salinity shape the wave's journey, refracting its path like light through glass. As signals reach Honolulu, coastal authorities activate emergency communications. Harbors prepare. Boats head for deeper water. Safety lies offshore, not near the docks. Beyond the horizon, the sea begins to rise. Silent, massive, approaching. As depth shallows, speed slows, energy compresses upward, building height and strength. Currents concentrate like rivers within the sea, multiplying destructive force in narrow inlets. Onshore, the warning sign appears. The ocean pulls back, exposing what should never be seen. Then comes silence, the calm heartbeat of the ocean before it strikes. Far offshore, the ocean surface begins to rise, a swelling wall that hides its true scale until it nears land. As depth drops from thousands to mere hundreds of meters, the wave slows and stacks upon itself. The first surge breaches Hilo's breakwater, converting horizontal energy into vertical destruction. Water fills the basin in seconds, tossing vessels like toys, amplifying through resonance. Pressure peaks near channel entrances. Forces measured at over 30 tons per square meter. Floodwater advances through low-lying streets, turning each intersection into a current. When the first wave rebounds, returning energy collides with the next, a deadly resonance cycle.
Behind the initial surge, a second wave forms, often higher than the first.
The shape of the islands channels energy, focusing impacts on curved bays like Hilo and Kailua. 6 hours later, the same energy crosses 38,800 kilometers, approaching California, Oregon, and Washington. In Oregon's rocky bays, water funnels through narrow inlets, increasing height and speed. Far south, the tsunami enters San Francisco Bay, where harbor currents turn the surge into oscillating flows. Even minor oscillations destroy moored vessels. Harbor resonance turns safe havens into traps. Returning currents erode the seabed, carving channels that reshape coasts for decades. From above, the pattern is clear. Rivers reversed. Streets become currents. Seismographs capture low-frequency roars. Long after the waves fade, the ocean still speaks. The energy dissipates in subtle ripples, aftershocks that remind how fragile equilibrium can be. Then comes silence. No sirens, no noise, just the sound of wind over water. Survey teams later map the patterns left behind, nature's fingerprints etched into the land. Across the Pacific, sensors fall silent, the ocean returns to rest. But its lesson echoes from Kamchatka to California. Beneath the Pacific, the seafloor now bears the marks of 2025, a permanent shift etched in rock and memory. From orbit, satellites measure coastal change and flood extent with millimeter precision. Over thousands of kilometers, drag and turbulence absorb what once was pure momentum. In just 9 hours, a quake in Russia rippled across an ocean to America's shore. This event proved how connected our oceans are. A single fault line can move entire continents of water. Preparedness begins with understanding. Detect, warn, evacuate, educate. Across the Pacific, hundreds of dart buoys and satellites stand guard, watching the sea in real time. When seconds matter, technology turns data into warnings that save lives. The storm has passed. The ocean breathes once again, tranquil yet eternal. Nature is not vengeful. It does not forgive or forget. It teaches. From space, our planet seems peaceful fully, a reminder that understanding its forces means protecting our future.
Event summary, magnitude 8.8, depth 27 kilometers, run-up height 15 meters, travel time to Hawaii 6 hours, energy 2.4 as 1010 joules.
This film is a 3D cinematic simulation created for education and awareness. It is not real footage.
Produced by StorM-SP Entor, where science meets cinema.
Like, subscribe, and share to raise awareness. Together we learn, together we survive.